You guys, welcome back to the channel. I ended up getting an iPad, Apple Pencil. It's been a blast. Wanted to go over how caffeine helps you stay awake. And we're going to kind of talk about caffeine and adenosine receptors and how they interact with one another in our central nervous system. So if we look over here at the neuron, your neuron is the functional cell unit of your central nervous system. Okay? So in here, we're going to call this the cell body. Okay, we're going to zoom in over here and kind of show what happens with ATP and what happens when ATP gets broken down. Okay, so ATP stands for adenosine triphosphate. ATP is important because it is functionally the energy currency of the cell. Okay, if we go back to cell bio, ATP is a massive role player in the electron transport chain. Okay, so ATP, if we break down the word, it means adenosine triphosphate. If we illustrate that in more of a simple drawing, we have the A for adenosine, phosphate group, phosphate group, phosphate group, right? Triphosphate. There's three phosphate groups. What happens is the breakdown of these phosphates, if you look at these bonds right here, that's really what helps create energy in the cell. Okay, so right here we have ATP because there's three phosphates. When these phosphates get cleaved, you can imagine that when that third phosphate gets cleaved, you're left with ADP, adenosine diphosphate. Okay, subsequently, we can cleave this phosphate bond, right, which this happens in every cell in the body, and then we're left with AMP, adenosine monophosphate. And then at the very end, if we cleave this bond, right, all of these cleavage of these phosphate bonds release energy. At the really at the end of the day, we're left with adenosine, right? Adenosine itself in the central nervous system is going to build up over time, right? It's going to build up, especially as the day goes on, right? So you're going to have high levels of adenosine. Adenosine, when it's by itself and elevated, right, is going to promote sleep because it's kind of showing that your energy stores are kind of wearing out throughout the day, right? So when adenosine rises, it is a sleep promoter. Okay. So ATP gets broken down, the phosphate bonds break off. At the end of that cascade, you're left with elevated adenosine, right? So if we look down over here, there's kind of a few things we can kind of illustrate, and I've drawn it out for you, and I kind of drew it in a different way. We've got adenosine over here on the left, and then we've got caffeine on the right. I drew adenosine in blue to kind of have a calming color, right? Because adenosine is going to promote sleep, right? So if we go over here, adenosine, right? When this builds up, think sleep. Okay. So what's interesting here is if you look chemically at the structure, see the similarities between that ring structure on adenosine and the ring structure of caffeine. That's called a methylxanthine, right? So caffeine is a methylxanthine. And if you really want to geek out, the methyl groups are these carbons with three hydrogens. Okay. So what's interesting is that caffeine, if you take a look, they're structurally, it's very similar to adenosine, right? So if we come up here and we imagine this caffeine molecule in your central nervous system, right? Adenosine is going to build up over time, and that's going to signal to your body that it's time to rest, right? So you can replenish that ATP that got broken down, right? So then adenosine, you can create more ATP throughout the day. Caffeine antagonizes, it's an antagonist to the adenosine receptor, right? So it kind of lodges in here. It doesn't quite bind with it, but what it does is it's gonna functionally block or make it harder, right, for adenosine to bind in there, right? You're gonna have circulating adenosine, but because of the caffeine structure, it makes it harder. It competes for the adenosine to bind to that adenosine receptor, right? And that's all up here in the central nervous system. You can imagine that these adenosine receptors are located, everywhere on the neuron. Okay. So what that's going to do is caffeine is going to block or make it harder for you to feel sleepy. Okay. So if we go down here, what's kind of interesting about that, a couple things about caffeine is that caffeine, and I wanted to talk about the half-life of caffeine, okay? The half-life of caffeine is about 6 hours. This this can, vary amongst people, right? That's because we have different enzymes that break down caffeine. So everyone kind of has a different response to caffeine on how quickly you can break it down, how you metabolize it with enzymes, okay? So if the half-life is 6 hours, the reason I wanted to bring this up is let's say you drink a double shot of espresso at noon. Fast forward to 6 p.m., you're still going to have one shot of caffeine circulating in your system, okay? You could do the same thing if you said, hey, I had a double shot at 3 p.m. Well, by the time you're getting ready to go to bed, let's call that 9 p.m., you're still going to have one shot, okay? And the same thing, if you had a quad shot, then you're going to have two shots in your system. I love quad shots of espresso, okay? I really wanted to illustrate that just to show that that's really how the system works. Now, of course, there's more nuances to it, but really just starting with how ATP, when it breaks down, you're using up energy. It's a signal to your body when that adenosine can kind of bind to these adenosine receptors. It's going to want to make you, sleepy, right? It makes sense. Well, caffeine antagonizes that receptor. Okay, it antagonizes that receptor, and it's going to make you feel more alert, right? Kind of helps with alertness. Can also work functionally in different areas of the body as well. But I hope this kind of helps illustrate the similarities between caffeine and adenosine and how they bind, how it helps antagonize the adenosine from actually reaching those receptors, right? Which is why you feel more alert, feel more awake. And if you drink caffeine late into the evening, you're going to have a harder time falling asleep. Now, everyone's different on how that works, but I hope this illustrates that. And I hope you enjoyed this video, and I got more videos coming your way shortly.